Alright, so this video is about your data analysis 3. It will help you to generate the decision tree to answer the questions. Alright, so if you open the module 6 and then if you go down for the class notes and then you'll find a JUMP practice guide. Right, so if you open this file, it will be like this. So here I just made the detailed steps so that you can follow and answer similar questions based on the decision tree. Right, so today we will just follow these steps one time, and then if you got stuck anywhere, you can always come back to check how you will get it through. All right, okay. For this example, this practice, we will use this JUMP file, which is the housing dataset. We have already talked about this in the part 2 video for this housing data. Right, so in this housing data, we have many variables, and I just made a summary of it. Right, so we have a table for the variables name and their descriptions. Right, so we say the total value of house will be the response variable we want to make a prediction. Right, so this is our y, the response variable, and then we have another variable is called the tax. So actually tax is just the total value of house times a tax rate, right? So actually these two are the same thing. So if you are predicting this, you cannot use tax to make the prediction of it because they have absolutely 100% of the relationship, right? So if you know the tax, you know the total value. So these two variables are the same thing. So for this case, the tax will be, we call it is rejected. That means this variable has the repeated information with other variables in this data set, right? So we say rejected. So if you see a rejected input, you need to just delete this variable. You don't count it in your analysis. All right, okay. Then the other ones will be your X variables, the explanatory variables, right? Will be the lot square feet, the year the house was built, right? And then gross area, living area, floors, rooms, number of bedrooms, number of bathrooms, and whether the house is remodeled or not. Right, so with this data set, we want to generate a decision tree. All right, let's see how to generate the decision tree. We go to analyze, right, and then predictive modeling. Right, in this option, choose partition for the decision tree. All right. Before you generate the decision tree, you need to choose the response variable and the predictors. So here, total value will be our response variable, right? So let's go easy first. So let's just choose for the gross area and number of floors as our predictors, just the two, for example, right? And then click OK. Right, so this is our first output without any tree showing, right? So this is the general information about this whole data. That's why it is called all rows. All right, and then if you click this button, split, you will say that this whole group is split into two subgroups by the gross area, right? So for this group is the gross area less than 3667. This group will be larger or equals to 3667. All right, and then split again. All right, and you will see that based on the first step of the splitting, you have the second step of splitting, also based on the gross area. But now, based on the gross area is less than 3,667 square feet, this group is divided into two groups, that it is less than 2595 or larger equals to 2595. All right, and then if you keep splitting it, you'll have this next step splitting, right? So here is a little bit interesting here. Sorry. So from the first step, this group is keep getting splitted, but this group is not, right? So this group is just keep there and no more splitting. So why is that? The system will calculate their effectiveness, that the system can determine that for the first time, making the groups based on this standard will separate this group as effective as possible. And then you'll find that, okay, based on this standard, next step, it is more effective to divide these two instead of divide this group. And then the same thing, after this step, the system will calculate the effectiveness for dividing the groups by this two, not this one. So actually, this group is more focused together. It is not as necessary as this group to be divided. So that means there is no needed for this group to be separated. All right, and another thing is, if you look at the variables, right? So the whole data set is divided into two groups by the gross area first, and then gross area second time, and then will be divided into two subgroups by the variable floors, right? Less than 2 or larger equals to 2. So actually, the jump divides the groups by the order of the variables like that, because if you show, because it is column contribution, right? So this table will tell you that it says the gross area have the contribution to dividing these groups into subgroups. The contribution is much more than the floors. So you will see that 94.46% of the contribution is from the gross area. So that's why if you look at the tree, most of the subgroups are divided by different standards of the gross area, not the floors. All right, so this is another way to tell you that's the contribution of each variable. All right, so now we have this output. Then let's come back to our practice guide. All right, so this output is the same one with our what we got, right? So let's answer the questions. How many splits have you done? How you can know that how many splits you have already done? There is a summary table at the beginning, at the top of this output. And in this output, in this table, it will tell you the R square, right? The root MSE, the number of observations, and number of splits, right? So this one we didn't talk about this in the regression part. It is also a very important value to estimate the regression, but here it is very not very, but it's a little bit complex, so we just skip this one. All right, so how many splits have you done? Number of splits you have already done is 3. Right, so it's easy to find from the output. Right, next, which variable is considered to be more effective? Which variable? We say the gross area, right? Because what? Because the system chose the gross area as the first variable to be divided into 2 subgroups, right? That means defaultly the system, they think that the gross area is more important or more effective to divide the groups into subgroups. All right, so this is the second question. Next one, how many leaf nodes does this decision tree have? Right, so first let's talk about the leaf nodes. What is the leaf nodes? We say the top of the tree, we call it is the root of the tree. All right, in the end we have many leaves, we call it is the leaves. In the end, for each leaves we have the leaf nodes. Right, so for every subgroup that don't have any next step subgroups, we call it is leaf nodes, or we call it is terminate nodes. That means the output, the decision tree just to end here. Right, so how many leaf nodes we have? 1, 2, 3, 4. Right, so we totally have 4 of them, because after these 4 you don't have any next step subgroups. Right, so next one, what kind of house is more expensive? Rank them. Right, so how we can say the house is more expensive? We say this is about the response variable, which is the house value, right? The house total value. So we can see that the mean here is the mean house value for this group. This is the mean for the house value for this group, and then the mean of this group, mean of this group. Right, so we say which group is more expensive. It will be this group, right? Okay, now how to describe this group of houses? This group is the houses with the gross area which is larger equals to 3667. Right, so actually this is number 1, the most expensive groups, most expensive group. Right, then next, what is the second expensive one? Will be this group, right? So based on the mean, right? So will be this group. Now how you can describe this group? Remember, if you want to describe a subgroup or describe a leaf nodes, you need to start from the end and then to the top until the root. Alright, so actually this group of house has the gross area larger or equals to 2595 and the gross area is less than 3667, right? So actually we say the house with the gross area that is larger equals to 2595 but less than 3667. Right, so this is the second expensive house group. Right, so what is this third one? Will be this one or this one? Will be this one. Right, so this is number 1, this is number 2, this is number 3. Right, so how you can describe this group? We say the house with floors need to be larger or equals to 2. And if you go up, it will be the gross area should be less than 2595 and the gross area is less than 3667, right? But if we draw the picture, right, so here is 2595 and here is 3667, right? So you have less than 2595 and then next one is less than 3667, right? So actually the common place is just here, right? So it will be with the gross area less than 2595. All right, okay. And the last one, the cheapest, right? So the cheapest of house will be this group, right? So it will be floor less than 2 and the same thing here, less than 2595 and also less than 3667, right? So it will be the gross area less than 2595. That's it. All right, so this is for this question. I just want to know that how to describe a leaf node. All right, and then let's just follow the steps. We say keep splitting the tree for 7 more times, totally 10 splits, and see what will happen if you repeat the process. Right, so let's just repeat it. Right, so now we have number of splits is 3, so we need to split. Now we have 8 splits and 2 more and 2 more. All right, so what happened? The tree is getting larger, right? In the end, we say at the beginning that this subgroup don't have any more subgroups, but when you keep splitting, when they jump, think, okay, now it is necessary to separate this group. It will separate this group into 2 subgroups and then 2 subgroups like that. All right, and then you will see that first the jump use gross area to separate the groups, and then gross area and floors, and then they can still come back to divide this subgroup by the gross area. So it doesn't mean that once you use this the gross area, you cannot use it for the next step. All right, okay. But here you don't need to worry about it. You can just keep splitting and see what does the decision tree looks like. right? And then another thing is, I just have a question. If I keep splitting for many times, what will happen? The tree is getting bigger and bigger until for every group you only have one observation. That means you totally separate them, just one observation per group, right? But is that necessary? Is that our goal? Of course not, right? We still want to group them, but we don't want to over group them, right? Okay, so let's come back to our practice, right? Okay, and then step 5 is for this step we have already talked about it, right? So I just want to show you again how to show this column contribution, right? So if you click this red triangle here, if this option is not chosen, it will be looks like this, right? And then you just choose it, right? And then you will have this column contribution at the end, just after the decision tree, right? So this is also the output I require for you to upload in the data analysis 3. So I need to see your column contributions. All right, okay, then say based on this table, how much does the gross area contribute to the estimation? It will be this proportion, right? So it will be 89.24%, right? How much does the gross area contribute to the estimation? Will be the rest, 10.76%, right? Okay, so let's continue. And we say that in the last practice, we say we can keep splitting until the end for many times, but actually it is not necessary, or it is not meaningful to do this, to do so many splittings, right? We need to stop at somewhere that you think it is good enough for splitting, right? Then next step, we will use the validation set to determine when to stop splitting, right? And then for this time, we just would like to cover all the possible variables into the analysis. All right, so if you would like to do that, we just do it, right? Okay, so let's look at the data. All right, analyze, predictive modeling, partition, right? And then we use total value as our response variable, and all other variables we don't have the keypad, so just move one by one. But if you have the keyboard, you can just use the shift to select all these variables together. All right, now I have one more variable. It is called the validation variable. All right, so I will use it right now in the validation space here. We will talk about how to generate this validation variable later. All right, and then we'll use this validation variable in this validation space. All right, and then click OK. All right, is there any difference you see from this output? It's actually one more option for you, which is for the go, right? Okay, so let's just skip this go first. Let's just do split. All right, and then if you do splitting, we can look at we call it is split history. Right, so this is the split history. All right, so what does that mean? We say the validation data is for the red line, right? The blue line is for the training data. All right, and then we want to see this is about the R square, right? So we want to see that at any point that the R squares for both validation data and training data keep the same. It doesn't mean that these two are the same. It means these two lines keep the same level, and then this line also keep the level the same. Then at that point we should stop. All right, so let's say just keep splitting. All right, and then validation, go to validation, then click OK, and then I want to show the split history. Right, so for now I don't have any splits, so it is just nothing there, right? So if I split once, you will see a starting point for these two data, the R square for these two data sets. If I split once, it will just go for the ones, right? And then keep splitting, you will see that these two lines just keep changing. And then when the tree is becoming larger and larger, okay, now I have 36 splits and I'm tired. Alright, and then look at this split history. You see that the R square for these two data sets keep changing, although a little bit, but keep changing. And for this red one, which is the validation data, the R square also keep changing, a little bit increased when you have more and more splits. All right, and then we want to find a point that the R square for the validation data doesn't change, and also the R square for the training data also doesn't change. At that point we should stop, right? But it is hard to find this point, and we are not that patient, right? So actually this additional option for us is the go option, right? This go jump will decide for you to know where to stop, right? So now if we click go, right, you will see this output. All right, so what does that mean? That means the jump think that at this point both the validation data and the training data, the R square doesn't change anymore. All right, and then how many splits we spend? 91 of them. Right, you need to do 91 splits to get this point that both of these two data sets has the R squared don't change anymore. All right, and then for this output, it doesn't show the decision tree. What happened is sometimes if you didn't show it, you just use the right triangle and then display option, and then ask jump to show the tree. And then the jump will show you the big tree. All right, okay, so based on this output, right, so let's come back to our practice guide. We say that once we use this validation option, we will have one more option. Except the split and prune, you have the go option, that the jump can decide for you where to stop splitting. Alright, so this is the split history, and also this is the output if we click the go, right? So we need totally 91 splits to stop, right? So the first question, how many splits are truly necessary, will be 91, right? Okay, how many observations in the training set? How many observations in the training set? How we can see it? Since we use the validation set, right? And then you will have 2 rows instead of 1, right? And then for each row you have the corresponding R-square, you have the root MSE, you have the observations contained in the training set, and the number of splits in AIC. Alright, okay, so how many observations in the training set? Will be 2848, right? Okay, how many observations in the validation set? Will be 2954. Alright, okay, which variable is considered to be most effective? How we can see it? To see which one is most effective, the easiest way is what? The easiest way is to show the column contributions. Right, so now these are the variables we include in our estimation, right, for the house price, right? And then you will see that this living area contributes almost all for estimation, right? So it contributes about 83%, right? And next one will be the lot square feet, which is 8%. And then gross area will be 3%, and floors will be about 2%, right? Okay, and this column contribution table actually tell you something interesting. Remember when we do the project 2, if you tried, you have many variables and you don't know which variable should be included in the model at the beginning. So actually it is very good try to use this decision tree, because the decision tree will tell you which variable will be more or most effective, right? So based on this column contributions, which variable is considered to be most effective? Will be the living area, right? Okay, and then next step we want to try, what if the response variable is recorded as binary variable? We say if the response variable is a quantitative variable, is a continuous numbers, then we call the decision tree as the regression tree, right? But if the response variable is categorical variable, then we call it is classification tree. Right, so actually we have 2 kind of trees that just depend on what kind of variable the response variable is, right? Okay, so here, just to close the output here, right? So here I just generate another variable. It is called the value larger than 500. All right, so what does that mean? I just use the total value of the house. This is in thousands, right? So if the total value of the house is larger than 500,000, then I record it as 1. Otherwise, if the total value is less equals to 500, it will be 0. Then, for example, the first one is less than 500, then it will be recorded as 0, right? The other way, if we have the house price, for example, this one 575, which is larger than 500, we will define it as 1. Right, so actually this variable is a binary variable, right? And it is the categorical variable. Right, now how we can generate a decision tree for this kind of response variable. We say we go to analyze. Again, the same thing, predictive modeling, the same thing, partition. All right, in the end, we do not use this total value. This is for the regression tree, right? We want a binary response, so value larger than 500. So we use this one as our response variable. And then to be easier example, we just use 2 variables, the same thing, the gross area and floors. I just randomly choose 2. There's nothing meaningful for here. I just want to make the example looks easier. All right, and then we need the validation here. All right, and then click OK. And then just go. Right, since the tree is not showing, I want to see the tree, so just to show the tree. Alright, so now you have something colorful, right? Okay, so what does these colors, what does this red mean? What does this blue mean? We say defaultly. In default, right, Jump will generate the red for the 0 category, and then blue for 1 category. Right, so we say if it is 0, that means it will be less equals to 500,000. If it is blue equals to 1, that means yes, it is larger than 500,000. Right, okay, now let's come back to our output. Right, so what does this group mean? It means this group all blue. Right, okay, so this group is all blue. That means blue is yes, and it is larger than 500,000. That means this group are all expensive houses. Got idea? Right, so what about this group? This group are all red ones. Red ones is 0. That means the house price is less than 500,000. Right, so that means this group of house are all less than 500,000. Right, so actually if you keep splitting it, you will see that there is no necessary for this group to keep splitting, because this group are all this kind of the same houses. All right, so this is how you read this kind of decision tree, the classification tree. Actually, there is no difference, but for this kind, you can also show one more thing. It is show split probability. Right, so if you show this, you will see that it will show you what is the proportion for 0, what is the proportion for 1 in this group, right? What is the proportion of 0, what is the proportion of 1 in this table, in this group. All right, and then again, you will see the counts for each one, but you don't have the means, because the means will be for the continuous variable, for the quantitative variable, right? But now we have the binary variable, then we do not have the mean for the response variable, right? So we have either yes or no. We don't have the mean of it. All right, okay. So this is about the binary response variable. Everything will be the same, just a little bit difference when you read the output. All right, and then another thing is in the data analysis 3, I want you to save your results in a PNG file. All right, so once you have a decision tree, you want to save it, right? And then in the data analysis 3, I want you to show the decision tree with the split history and also the column contribution, right? So I want you to show all of these 3 things: the decision tree, split history, and column contributions. All right, now how you can save all these outputs as a picture. You see that there is a hiding to list, right? So I will show you again. All right, so if you click that, it will show up. All right, click File. All right, Save As. All right, and then you can just say, okay, let me try again. Save As. Okay, now you need to save the file style, which is PNG file, and then just save it. So since I have already saved it, and then just replace it. All right, so this is all your output here as a picture. So actually you can save it as any type of file, but for data analysis 3, I just ask you to save as PNG file. Right, so this is the way how you save your output. Right, and then once you have the output, I need you to upload on the data analysis 3. All right, so this is actually it is the last step, but for step 9, I just want you to know something extra, right? So it's about the validation set. So in this data set, we have already generated this column, which is the validation set, right? Validation column. But what if I don't have this column? For example, what if I just delete it? If I don't have the validation set, how you can set the validation set by yourself? There are 2 ways, right? The first way is analyze, predictive modeling, and then go partition. All right, and then here when you define the y and then define the x, you can specify the validation proportion, right? So actually sometimes, most of the time, we just say it's about 0.2 to 0.5 because we want to leave more for the training set, and then the validation set will be about half of the training set. So here I just set it as 0.25. Right, So that means 25% of the whole data set will be on my validation set. So how it will be chosen? It will be randomly chosen. Alright, so you do not have this variable anymore. The jump will just choose randomly 25% of the data set as the validation. And then you can click go. And then you will have a different result every time, because every time you do this, the system just start over the random process. So every time you will have a different validation set in the back. Right. Another way is to make it stable is to generate a column like what I did before, right? So just analyze, and then predict modeling, and then there is an option here, say make validation column. All right. And then there it will be a table you need to fill out that, okay, I want the validation set to be, let's say 0.20, let's say change it, let's say 0.3. And then all the other ones will be our training set, so we choose 0.7. All right, and then we say we gave a column name for this validation set, so we just call it is validation. Right, so that's when you add into the table, you know it is for the validation. Right, and then there are several methods to choose the validation set. Right, so you can use different formulas, but for our case, we just randomly choose the observations from the whole data set as our validation set, right? So we just call it as formula random. We just use this formula to choose the validation set. So once you click this variable is created, right? Then every time you make the decision tree for the validation, this variable will not be changed anymore. It will not be random for every trial. This one will keep the same. So this is the difference between these two methods. All right, okay, so this is the last thing I want to talk about for the decision tree. But if you have anything else you want to talk about, you want to explore, you are very welcome to email me to ask, or even if I don't know the answer, we can search together. All right, okay. I think it is enough for you to complete the data analysis 3.